All right, so here's your derivatives. Your first, e to the x, we'll have two examples to show why e to the x, the derivative is e to the x. This is the important one though, because it can be used even with the e to the x, and that's how we're going to show. So if you have y equals b to the x, with a base of b being any constant, so like 2 to the x, 3 to the x, 1/2 to the x, when you take the derivative, you take ln of that value, the base, whatever it is, times the base to the exponent x. And that will be every time. The derivative of ln x is 1 over x. Y is e to the x, e to the x when you take the derivative. Let's follow rule 2 using e to the x. So rule 2 says when you take the derivative, you take the base, which in this case is e, and remember, e is a number. So when you take the base, you take ln of the base, and then you multiply it by the exact same base to the power of x. However, when you look at ln of e, what do we remember about ln and e? It's 1. They're inverses of each other. So your y prime is e to the x because that equals 1. So given this equaling 1, let's do the derivative using first principles for that f of x. Okay, so if that is your limit or your equation for the derivative using first principles, let's sub in for our function that's e to the x. So if we go to put in, we still have limit. That part stays as h goes to 0. F of x plus h, so instead of it being x, it now has to be x plus h. So we have e to the x plus h minus our f of x, which is e to the x, all over h. Now let's look at this. If you had 2 to the power of 3 times 2 to the power of 5, how else can you write that? 2 to the power of 8, you add the exponents. So that's the same thing as 2 to the power of 3 plus 5, right? So if we had it written like this, would we be able to go back to that step? Okay, so let's try that here. Using that logic, that's what you could simplify this part to. So let's take a common factor. So we have limit as h goes to 0, and we're going to factor out e to the x. So we're left e to the h minus 1 over h. Let's look back up here at what I gave you. We know that that equals 1. So go back down here and look right here. We know, we just found out that that equals 1. So all you're left with is the limit as h goes to 0 of e to the x. And if you sub in h of 0, are there any h's here? Okay, so let's say we subbed it in. All you're left with is e to the x, which is the derivative. What rule do we need for part A? Yeah, you need the second one. The derivative is you take the ln of the base, which is 3. So you take ln of 3, and then you multiply it by the exact same exponential. That's a good question, though. Okay, so looking at, hold on, guys. Okay, when you look at ln 3, remember ln 3 is just a number. It's a constant, but it's a decimal. So we're not going to write it as the crazy decimal you're missing. Keep it exact. So leave it as ln 3. So for B, there's different ways that you can do this, but what's one rule from chapter 2 that we can use to solve this? The constant multiple rule is leave the constant and take the derivative of the function. So our y prime would be 2, and then what's the derivative of e to the x? E to the x. So that's your derivative. The alternative is the product rule. So if you look at this being your first function and this being your second function, your y prime will be the derivative of the first. What's the derivative of 2? Times the second, we'll still say 0, plus the derivative of the second, which is e to the x, times the first, which is 2. And so you're going to end up with the same thing. And I would like to give a shout out to Varsha. That's your derivative, Varsha. Okay, and now you're going to sub in your x value to find your slope. So you have y prime equals 3 e to the ln 4. And what do you remember about e's and lns? They're inverses, so they cancel each other out. So all you're left with is 3 and then times 4. So your slope is 12. So everybody notices now, come on, that we have our slope and we have our x value, but we don't have the y value. So to find the y value, we're going to sub this into your original. But what do you notice about your original compared to your derivative? It's the same. So your y value for ln 4 in the original will be the same. So when you substitute it in, you have 12 equals 12 times ln 4 plus b. This will not simplify any, so you just rearrange and solve for b. So you have 12 minus 12 ln 4 equals b. And now you just put your final equation, which is y equals 12x plus 12 minus 12 ln 4. So when the other alternative you could do, which I'm not expecting you to do, would be you could also make a common factor. But you can also just sub it in as we've done there. And that's your equation. Bye, Varsha.